Hi, welcome back to my channel. So in the previous video we already learned the differentiation of trigonometric functions. So today we will enter the logarithm functions, but before that I would like to explain one example that student might be confusing as these examples. Okay, let's say y equals to cos 2x. So now we know that here has a constant inside the brackets. So what we usually do is applying the chain rule. So chain rule. How we gonna deal with the chain rule using the trigonometric functions? So when we find the dy dx, we know so it's actually the same as the chain rule. We let in what is inside the brackets become u. We can, if you want the short method, we can let u equals to 2x and du dx is equivalent to 2. Alright, so we know that dy dx is equivalent to dy du times du dx. Where dy du, you know that y is equivalent to cos u, and dy du is equivalent to sine u. Right, so u is equivalent to 2x, so sine 2x, so it's equivalent to sine 2x multiplied with 2, so it's 2 sine 2x. Oh, I'm sorry. So when we differentiate cos, it will get negative. As I say, when differentiate with cos, it will get negative sign. So if you want to eat fast, you can just ignore the let you can just differentiate if you are fast enough. So hence we can deduce this formula: d dx sine fx is equivalent to f prime x cos fx, I'm sorry, and d dx cos fx will be equivalent to f prime x negative, since we are differentiating the whole, and you become sine x sine fx. Here is the formulas. Okay, the formula is actually come from the chain rule. So now we enter the logarithm functions. Logarithms functions. So how we differentiate the logarithm functions? So let's say we have fx equals to ln x, f prime x will equivalent to 1 over x. So in general we can just memorize these things, but I can tell you how to derive it. So how can we derive it? So let's say we have fx equals to ln x. So now I will use this method. Let y equals to ln x. I'm sorry. Let y equals to ln x. Then how we cancel out the ln? In general, we know that ln with e, log with 10. Yeah, right? So how we gonna do this is we add exponential for both sides. Exponential of y, exponential of ln x. As we know the general formula ln anything, let's say I ln a flower, e ln a flower will be equivalent to a flower. Alright, so here is the natural cancel out. So that means that ey will be equivalent to that. So now we apply the implicit formula, implicit differentiation. With d dx both sides, ey equals to d dx of x. Of course, here we know that ey, d dx ey, let's do it separately. D dx ey will be equivalent to, as I hope you remember that d dx is equivalent to d dy times dy over dx. Right, so I want to change term to y, since here got the y variable here, so I change dx to dy and ey, and my multiple back with dy dx. So we know that differentiate ey, what will we get? Actually we will get back the same thing, which I will talk later. So so differentiate of ey, we get back ey times dy dx, and here we get ey dy dx equals to 1 when d dx 1 x equals to 1. So Now we move all the terms beside dy dx to the right hand side 1 over ey. Since we know that ey, what is ey? Ey is equivalent to x, right? From here, so it's equivalent to 1 over x. So this is how we derive the logarithm functions. The ln x and the f prime x will be equivalent to 1 over x. However, this formula is only true when x means that there is no other constant like 3x, 5x, 6x, 99x or something. That one we will further discuss it later. So yeah, I will discuss it now. So how we gonna apply it in the practicals? We are using the chain rule to derive chain rule for ln x. So let's say I give an example, y equals to ln 3x plus 6. So how we gonna derive it? We want to find dy dx. My question is find dy dx. So how can we find dy dx? So you may know that here got the brackets, right? So as a chain rule, I say let the things inside the bracket become u. So we know that u equals 3x plus 6 now, and you can du over dx, we get 3. Yeah, here is constant, differential constant, we get 0, and y equals to ln u. So dy du is equivalent to 1 over u. From just now, from the derivation we get here 1 over x, now it's du, so it's 1 over u. Alright, so now dy dx will be equivalent to dy du times with du over dx. Alright, so dy over du is 1 over u times with 3, so it's 3 over u. Where u, we know that u is 3x plus 6. 3x plus 6. So now actually what is this? Let's look at this. What is actually talk about? You can see clearly that this 3 is about the u prime, and here is u. So from here we deduce that when we have ln fx, y equals to ln fx, then the dy dx will be equivalent to f prime x over fx. Yeah, so this is the shortcut. I can say this is the shortcut for the ln fx. Is any function. We put the differentiation of the functions on the numerator and put the original function at the denominator. So that is the differentiations of the ln fx. Alright, so that is about the logarithms. So now we will talk about the exponential functions. So how we differentiate exponential functions? So let's say we have fx equals to ex. Alright, so how we deduce? So I will tell you f prime x is equivalent by applying the first principle. Everything we come from the first principle of differentiations, because yeah, that is the first principle, right? Yeah, okay, so we know that we substitute delta x minus ex over delta x. So yeah, it's the same thing. So we know that ex exponential, we must know that when it's plus, we can separate out, become e delta x minus ex over delta x. So now let's go move on. Delta x 0. Now we can factorize out the ex, and here is e delta x minus 1 over delta x. Right. So now when delta x approaches zeros, from theory, as delta x approaches 0, e delta x minus 1 over delta x is equivalent to 1. You can check with calculator when you put the delta x is very small value, like e to the power 0001 minus 1 over 0001, and is equivalent to 1. Alright, so now that we know that this is 1 is equals to 1, so we get limit delta x approaches 0 ex. So here we get ex. So here is the derivations for the exponential function differentiations. So, but this one is for the general users only. In questions, of course, in STPM questions, I don't think they will ask something simply like this. They will give a complicated functions like y equals to e fx. Fx is any function. Fx can be 3x squared plus 8, 4x plus 5, 6x plus 9, something like that. So how are we gonna apply it? It's actually we using the chain rule. Chain rule is everything. So how are we gonna do this? Now we are not let the terms inside the bracket become the u, but we let the fx become the u. So you know that y equals to eu, right? So dy du will be equivalent to eu, as we implies that just now we learned that ex differentiated become ex since is u, so eu. Alright, so u is equals to fx. So we differentiate, we will get f prime x is any functions, okay? So dy dx is equal to dy du times du dx. Dy du is equals to eu times the f prime x. So we know that u is equals to fx. So we subtract, we get f prime x e fx. So here is a general formula for the differentiation of exponential functions. Sorry. So let's say example. I have y equals 3x plus 5. So how are we going to differentiate it? We just apply the formulas, apply the shortcut. Alright, so f prime x, we know that here is the fx. Fx equals to 3x plus 5. When we differentiate these things, we will get 3. Here is differentiate constant, we get 0. So so we put that f prime x in front, 3. Here is just copy back 3x plus 5. So here is the answer. Right. So the last theory is much important, but because STPM this period they're quite famous, they're quite popular to ask students about the dy dx equals to ax ln a. Here, these terms is very tricky, I can say here. So when y equals to a to the power of x, where a is a constant, they try to think about the hot expressions, I think, so they come up with this. So how are we going to derive it? So in exam, if you don't know how to do, I suggest you just derive it because it's very easy. How are we going to do that? So we add ln. We add ln at both sides, so we get ln ax. As we know that this x can be transferred to the front, I hope you all understand. Ln y equals to x ln a. We can bring the x in front of the power. So since a is a constant, so we know that ln a is a constant. It's just like ln 3, ln 5, ln 6 is a constant. So ln a is a constant. So now we differentiate both sides with respect to x. That means we are doing the implicit differentiations. So we are differentiate each term with d dx. So we get d dx ln y equals to d dx x ln a. So now we know that ln y. How we differentiate ln y, as I just taught already, here we can just change the d dx to d dy ln y, but we need to multiply by the dy dx. And here d dx ln, we copy back to x ln a. Alright, so how are we going to do this? So let's see. d dy ln y. d dy ln y, as we know that d dx ln x is equivalent to 1 over x, right? So now it's the same thing since 1 over y dy dx is equivalent to d dx x ln a. As I say, ln a is a constant, so it's just like 3x ln 3x. When we differentiate the ln 3x, we will get ln 3, right? So here is a constant, so we will take back the constant, so we will get the ln a. Now we only want dy dx, so we move everything terms else to the right hand side, so it's equals to y ln a. So what is y? Now, just now we let y equals to a to the power of x. So it will becomes ax ln a. So when the question give something like y equals to a to the power of x, don't be panic. I know this is not inside the syllabus, but they usually want to test you understand or not. So when you see this, you know that dy dx. You just copy back ax and you add a ln a here, where a is a constant. Right. So another tricky part that will come up is when y equals to a to the power of fx. That means here is not only a single term x, is a function of x. For example, 3x plus 6, 5x squared plus 6x, something like that. And you know that when dy dx, you are just implies the chain rule again. So it's f prime x. It's f prime x times with the a fx, and don't forget the ln a here. So here is the formula you can use. Alright. I think here, okay, I will teach about something is very special case that might come out. It might come out because they want to test your understanding. So if it come out, you must be careful about these things. Since we know ln x is equivalent to log base e x. So how if I give you the base, not e? So this is the tricky part in exam that can come out. So let's say we have y equals to log ax. So how are we going to find the dy dx? Where a is a constant. Let's say I give you a log 6x like there. So it's very weird, right? So I know, but never mind, we will try to solve it. So y equals to log ax. How are we going to do that is here. Let's say I give you something like y equals to log ax, and yeah, I just imply I give you this y equals to log 10x, so you can easily see. So y equals to log 10x. I want to change it to the log ex. I hope you all still know how to change the base. So log e, we put the base here. So we change the base into e, so we can imply. I don't care what you give. I just want to change to ln. So here is my method. Alright, so I can get like here. So here we become ln x and ln 10. It's not necessarily 10, it can be 3 or 4, 5, any term of numbers. Okay, so only the term here will be changed. Alright, only the term here will be changed. Okay, so ln 10, and now we know that y is equivalent to ln x or ln 10. So if I want you to find the dy dx now, I think it's not a problem really, right? Since y, you can take out the ln 10. y 1 over ln 10 is actually a constant, ln x. So constant, we are not bothered about it. So if you want to find the dy dx, it's actually 1 over ln 10 you times with the 1 over x. Right, because you differentiate the ln x, we get 1 over x. So here we get 1 over x ln 10. So here we get the answers. Of course, if the answer want you express back in the term of log 10 or log a, anything, so we can change it. How are we gonna change it? We can change it to log 10 to the e over x, because when we change this part here, how are we gonna change this? Okay, let's see. If you want me to show how to change this, I will show. Ln 10 is equivalent to log 10e, right? So log 10e, if you want to change back to the, I'm sorry, here is log e to the 10, log 10. So now I change back to the base of 10. So yeah, it's just like here. So I copy back here, and I get log 10e. And now log 10, we know that this one is equivalent to 1. So 1 over log 10e. So we actually, when we substitute here, so we will get this is the answer. So in summary of this summary, we know that if we have y equals log ax, a is a constant. So we know that dy dx will be equivalent to 1 over x log a e. Here is the formula you can memorize. Or if in exam you really cannot memorize so much thing, I can suggest you to derive. You can derive it, yeah, because it's not really long. It's quite simple also. So yeah. So if given log a fx, so you find the dy dx will be equivalent to f prime x over fx log a e. So here will be the answers. You can memorize it or you just do it. Derivations, yeah, you change it to the, I don't care what you give me, a base of 3 or 4 or 99. I just want to change it to what I'm familiar, that is log base e. Then we can imply the ln, implies the differentiation of ln, then we get the answer. So here is the two formula. If you don't want to suffer yourself, you can just memorize the formula and apply it when come out. Alright, I think here is the end of the logarithm functions. Next video I will explain about the differentiation of the inverse trigonometric functions. Alright, thank you for watching.